Hi, my name is Julia Lane, and I'm going to be talking to you about uh, machine learning and give you some sense of what its uses for public policy. What I'm going to try and do is try and explain what it is, how it's used, and what the particular application is in terms of machine policy, terms of public policy. So one of the challenges with machine learning is there's a lot of different definitions. So it kind of gets this mystical thing associated with it. It turns out that there's lots of different definitions. Tom Mitchell famously said, a computer program learns from experience E, what that means, data, on a particular task, and it's evaluated on some kind of performance measure. And what it does is it learns as you give it more information, as you increase the experience. Simon says it's an iterative learning process. And so what it is you give it a task, you give it some information, you then give it additional information, and it keeps improving. So there are a couple of key thoughts here. One is the notion that there's a task, there's a clearly defined task, there's a set of data, and there is some kind of metric that is being used for evaluation purposes. And that essentially is what a lot of statistics is built on. What machine learning does is it does a lot more in terms of that learning aspect. So here are a bunch of different other definitions. Susan Athey, who is an economist, talks about the goal of machine learning as being prediction and classification or clustering and grouping tasks. So those are the main kind of areas. We'll talk about those very practically in terms of public policy in just a minute. But if you take a look at these different definitions, that same common theme comes up. It learns, you provide information, you evaluate it, you identify regularities, and then you're going to make a prediction. So it's got multiple terms. You'll hear about data mining. You're trying to figure out what's going on in massive amounts of data. In statistics, which is where most social scientists and most people trained in public policy come from, we think about it as inference or estimation. Engineers call it pattern recognition. So many, many different terms, but the core notion is it's an algorithmic approach to taking in lots of information, doing analysis of it, and then improving as it gets provided more information. So here's a very nice little picture that is put up. Essentially, what you're going to do is you're going to train a model on some past data and predict. And you're going to try and iterate on that and then use that to predict out into the future. So it's very different from regression. What typically we use regression for is to understand behavior. We take data, we estimate a model, and then we look at the coefficients and we try and figure out what the coefficients mean. Machine learning, in many cases, is it's a straight algorithm. They can build a very complicated algorithm. They don't care about why it works. They're more interested in, does it work? The focus, instead of behavioral analysis, is largely prediction. Can I do a better job of figuring out X? That means that it can be applied to a lot of different tasks. Regression, we're typically talking about people or business behavior. What you're going to see in a minute is the wide variety of tasks that you can apply these algorithms to. And because it's set up to handle large-scale data sets, there are many, many more variables that can be used. Public policy, we're used to thinking about a quite narrow specification. We get criticized if we throw in too many variables. In machine learning, that's a feature rather than a bug, and that's a little bit of a joke. So what does machine learning do? Well, you can improve a model by acquiring new knowledge, that is acquiring new facts or acquiring new skills. That means putting in a different type of model, or doing a better job of solving the problems more accurately and more efficiently. So here are some examples, and again, this is taken from Raed Ghani. So when we think about this, you can think about how are we learning how to drive a car? So you can see there's someone at the top left who's sitting there and driving a car. Well, the car is driving and they're reading a book. So how do you tell a car to drive? Well, an old-fashioned way would be to try and think about all the different rules that you would put in place. So when you think about the way in which we tell people how to do things, we're normally saying, well, I'm going to tell you how to do this and how to do that and how to do that. But when it comes to complex tasks, there are too many rules to write down. So what the machine is going to do is it's going to take data. You're going to have it figure out how to do a simple task, and then you're going to make it do more and more complex things because it's going to learn from experience. That's how facial recognition works as well. Machine learning, you give it a person's face, and initially it doesn't know what an eye is or what a nose is or what a mouth is, but what you do is you train it as it gets more and more information. Used in other situations, obviously with fraud detection, it's being used to recommend Netflix videos, identify friends, to help you answer questions in Jeopardy and so on. So it does a whole bunch of very complicated sets of tasks. So how can it be used for public policy? Well, if you think about program management, the way in which we typically tend to set things up is we set up systems that have a bunch of rules. If this, then that. If this, then that. If this, then that. And so human beings are trying to figure out what those rules are, and then they're trying to apply them. The advantage of machine learning is instead of having rigid rules that are encoded at the top that people have to obey, machine learning is going to help us automate and scale that approach. And the advantage of government programs is a lot of times we have administrative data. So massive amounts of data that are generated from the administration of government programs. So administrative records, which might have millions of transactions on individuals, households, cases, people, can be used to train a model and generate rules automatically rather than just have to encode them. And the good thing about that is if you were to try and get a domain expert, like someone who is running a workforce program or a TANF or a SNAP program, trying to get them to sit down and write down a bunch of rules that are going to change anyway is A, not a good use of their time, and B, there are maybe too many rules for them to write down. So what they're better at doing is if you give them a set of options, they're better off saying right, wrong, yes, no, and then going back and having that fed into the machine so the machine learns. It's the same thing. So when you think about the machine learning approach, it gets used for public policy in many, many different ways. It gets used to describe the past, figure out, for example, how do I cluster firms into different sectors? How can I use text analysis to cluster like documents into different areas? Can I group people into different, by different characteristics like market segmenting and so on? The detection is, can I predict fraud? Can I predict how someone is going to vote? Can I predict, which political party they're going to belong to and so on? Or can I predict if they're going to skip bail? That's another example. I could predict the future. So can I figure out, based on a set of characteristics, who's going to get lead poisoning? That costs billions of dollars a year in the effect on young children who get lead poisoning, and it has long-term consequences. How can I predict that in advance? Trivially, in terms of behavioral change, Normally, we don't use machine learning for causal inference, but you can use it. Amazon, for example, is famous for having what's called A/B testing, where you change the color or you change the position of a particular piece on their website, and they use it to try and figure out how does it change behavior, does it induce you to click on it. So how do we use it in public policy? So the biggest thing to think about is machine learning is not a substitute for thinking. You have to be able to think about your data, have to think about the problem, and specify it in a way that is conducive to a public policy problem. So the first step is define your policy problem in a way that is amenable to being handled in a machine learning environment. And my colleague Brian Kim will talk about that in another one of the videos. I'm just going to set that up for you. Then you want to map it to a machine learning problem. Then you need to figure out what data are needed to answer the question. So for example, if I'm trying to predict whether someone an ex-offender is going to recidivate or reoffend, then I'm going to need data on corrections and on the same individual over subsequent periods. So I'm going to need longitudinal data. And if I'm interested in the effect of workforce experience, I'm going to have to incorporate information from administrative records from a workforce agency and put those together. Then what I've got to do is I've got to clean it, process it. You'll see that that is an enormous amount of work, but it's very important to have good data because, as they say, garbage in, garbage out. Then you've got to think through what are the features. Now, in social science, we talk about feature, or in statistics, we think about features as being variables. In computer science, they talk about them as features, but it's really the right-hand side variables. Then think about what methods to test and to use, and then evaluate the different approaches. So in subsequent videos, you're going to learn about different methods. And then, of course, critical to this is deploying it, maintaining it, updating it, because the world keeps changing and your model and your analysis should be as well. So this essentially is the organizational structure that we have set up for these classes. And what you'll see is formulating the problem, getting the data, storing and linking the data, processing it, exploring it, and then the deeper analysis is machine learning in here, and then evaluating it. So this is kind of where the machine learning fits in to the public policy process. It's part of the bigger package of understanding the question, how you're going to do the work and do the analysis. So thank you very much for listening. I look forward to getting your feedback later on.